Hi, welcome to our ProAV Academy series on tech terms, where we sit down with Alister Chapman and chat through some of the technical terms that just come up again and again in this industry. Alister is one of the best people I know at explaining complex technical concepts, so hopefully, just by casually chatting with him each one of these terms through, these videos can just help clear up some of the confusion that might be out there on each of these terms. Today we're explaining what we mean when we refer to a camera's native ISO and why you need to always keep it in mind. Native ISO is a term that's used a lot with cameras as to finding the best and fine-tuning the best image from a camera. What do people mean when they say the native ISO of a camera?
Yeah, so the native ISO is effectively the natural sensitivity of the camera, and what we mean by that is when you're not adding any extra gain or taking any extra gain away from the way that camera is operating. It will vary from camera manufacturer to camera manufacturer as to what that native ISO is. It also varies depending on the size of the pixels on the sensor and things like that. But generally speaking, that piece of silicon that is the sensor will have one actual sensitivity, and obviously we can add gain and take it away in the camera, but as soon as you do that, you're not at that camera's native ISO anymore.
So what are the implications of moving away, either higher and adding gain to go brighter, or negative gain to make it darker?
The implication of going away from the native ISO is generally a loss of dynamic range.
Right.
So we can add gain and the picture gets brighter. It gets noisier as well. We could take gain away and the picture will get darker. But the side effect of doing that is generally a loss of dynamic range, especially if we start to take away a lot of gain. So generally the sensor and the output of that sensor is mapped so that when the sensor is got zero light on it, it's black, is our zero recording level, and when the sensor is at the point where it's about to, what we call saturate is the technical term, where you can't put any more light on that sensor and get any increase in output from the sensor, so we might also call it the clipping point of the sensor, the overload point of the sensor, is mapped to our peak recording. So the two are mapped really nicely, and a lot of engineering goes into making sure everything's optimized, so black is black, and the maximum brightness that the sensor can see is mapped to our maximum recording level. Now if we reduce the gain of the sensor, we're going to make the signal that comes off that sensor smaller. That's the only thing that can happen when you reduce the gain. And the problem there is that now this effectively smaller signal won't ever fill our recording range. So we're no longer optimized. We're wasting part of our recording range. We'll never get to 100%. So you might be fully exposed, you might be clipped, but your recording might only be reaching 70 or 80%, and that's not desirable at all. So you never want to take gain away. If we add too much gain, the opposite happens. So instead of being nicely matched like this, we add some gain, this signal from the sensor becomes bigger, and it now exceeds what we can record. So we can no longer record the full dynamic range from the sensor, the full potential dynamic range. So generally, if you're shooting in particular with log or with raw and all of these things, where you are trying to capture everything that sensor can deliver, you want the sensor to be operating at its optimum settings, the processing in the camera at its optimum unity gain, and then everything lines up and matches nicely, and you'll get the very best that you can from that camera. Now, modern cameras, it is possible to have more than one native ISO.
Right.
And what's actually changing here is there's far too much to go into in this little short video, but we're actually fundamentally changing the way the pixel operates on the sensor. So the pixel's made up of two parts. There's the light sensitive part, and then there's a bit underneath that or next to it that's called the image well, where the output of the pixel is stored. And by electronically making that image well bigger or smaller, we can change how quickly it fills up. And if it fills up more quickly, effectively the sensor is more sensitive. And if it fills up more slowly, the sensor is in effect less sensitive. So by electronically changing the pixel, the structure of the pixel, we can have one or two different native ISOs from the same sensor. But we're not adding gain, we're not taking gain away, so all the gain stuff remains the same. We're still at zero gain, added, zero gain taken away, because we're actually changing the way the sensor itself operates to give us these two different sensitivities that gives us then dual ISOs in the camera. It's really clever stuff that's going on. I mean, this stuff is microscopically small, and we're talking about how many electrons you can actually hold and things like that. It's amazing engineering that's going on to do this. It really is.
So what's the real world benefit of being able to do that?
Right, so the real world benefit of having dual ISOs. So whether you're Sony, whether you're Panasonic, there is almost always a small increase in noise when you go to the higher native ISO of the camera. It's just, you can't actually, you're not suddenly being able to get more for nothing. There's always a penalty to pay. So when we have a dual ISO camera, there is almost always a little bit, but only a very small amount of extra noise in that higher base ISO, a tiny bit more. Typically we're looking at something, if we take Sony's Venice as an example, 500 ISO is its low ISO and 2500 is its high ISO. Now 500 to 2500 is the equivalent to about 14 dB of gain, something like that, if we were adding gain to change the sensitivity. Now 14 dB of gain would add a lot of noise, because that's going to amplify the noise by, we're talking about 2, 4, 6 times, something like that. It'd be 6 times noisier. Whereas the difference between 500 ISO and 2500 ISO is tiny amount of difference in the noise. If we were to add enough gain to the 500 ISO to get the equivalent through gain to 2500 ISO, the image would be 6 times noisier, and it certainly isn't that big a difference. So dual ISO allows us to have a camera that can operate really well in brighter light conditions, where we don't need tons of ND perhaps to get a shallow depth of field. At the same time, when you then need to shoot in low light, you can raise the native ISO up to the higher ISO. The camera will perform much better in that low light without getting ridiculously noisy and everything else. So it's a really nice feature to have.
I think this is where some people have got a little bit confused along the way, because I hear an awful lot of people talking about native ISOs in relation to how noisy their footage is. And if you want to get the cleanest possible footage, well, you need to know what your native ISO is and things like that. Is it linked at all to noise and things like that? Or
well, generally when you're operating at the native ISO, the key thing is you're not adding gain. So the thing that tends to make your camera look noisier than it could be is the addition of gain. Every time you add 6 dB of gain, which would be the same as doubling the ISO through gain, then you will double your noise. So add 6 dB of gain, twice as much noise. And it's every time you add another 6, it's double again. So if you add 12 dB of gain, you have 4 times as much noise, because it's doubled and then doubled again. And each time you go up a stop in ISO, so each time you double the ISO, it's the same thing. So if I start at 500 and I go to 1000, twice as much noise. This is through gain as opposed to a native ISO. If I then go to 2500, it's double again, so it's 4 times as much noise.
Yep.
So generally in most traditional cameras, yes, you can raise the ISO, but it's generally done through a gain function. It's done by adding gain, by amplifying the signal, and as a result it gets noisier and noisier and noisier. So with most cameras, the secret is to finding what the camera's base ISO is and using it at that, because that's the same as 0 dB of gain, 0 extra amplification. But I think what catches a lot of people out is the fact that different gamma curves have different ISOs very often.
yes,
So gamma, this transfer function that gets you from the sensor to your final picture, has gain of its own. So different gamma curves have different gain levels in the gamma curve. So when a camera manufacturer rates their camera, different gamma curves will give you a different base ISO number.
that's,
and that's
why
where it gets
you
really
quite
confusing.
often see log having a different native ISO than
Yes.
normal cameras.
because the gain of the gamma curve is taken into account when
Sure.
working out what the ISO is.
What about if people are just trying to get the cleanest, most noise-free image possible?
Generally speaking, you go for the lowest ISO that you can.
Right.
The only thing you have to watch out for is that that's not a negative gain ISO. So some cameras might have a base ISO of 800. That camera might have the ability to use -3 dB or even -6 dB gain. So you're actually subtracting. So that would give you a 400 or a 200 ISO settings, but those are going into the negative gain territory. And that's where you might have a problem where you can't reach 100% peak recording level. So yes, you will have a clean picture,
But you'll sacrifice your dynamic range.
You'll maybe sacrifice some dynamic range or sacrificing your ability to reach 100% in the recording. And that's something to watch for. Most cameras don't go into negative gain territory these days, but some do. So it's something to watch for. And I mean, the camera manufacturers, I have to admit, aren't terribly good at explaining this to us and telling us. It should be in every camera manual what those native ISOs are.
I guess it just comes down to testing your camera and knowing your particular tool of choice.
And don't be afraid of using dB. I know today it's really fashionable to use ISO to get your equivalent sensitivity of the camera, but you have to understand that in an electronic camera, ISO isn't really the sensitivity, it is the exposure rating of the camera. So if you're using a light meter, you set it to the camera's light meter and you will get the right exposure. But it's not the sensitivity of the camera, because that ISO is affected by gain. And gain isn't sensitivity, gain is amplification. So you have an ISO rating, so you can use a light meter to expose it, but it's not necessarily the sensitivity, it's more of an exposure rating. So it's slightly different. So if you have a camera with the option to show gain in dB, that's actually going to tell you exactly how much amplification is or is not being added. So if you're at 0 dB gain, you are at the native ISO or the native sensitivity of the camera. So it's actually a much safer way to work in many regards. 0 dB is always going to be optimum.
Interesting. Thanks for watching. I hope that was helpful. Keep in mind, we also do a whole range of ProAV Academy workshops held right here in our UK showroom, where we cover a whole range of topics, from audio to post-production, camera techniques, business tips, lighting tips, and many more. The main aim of these workshops is to help our customers learn and develop their skills. And there's something about face-to-face training which can just never be replaced by videos like this one. So if you're in the UK, please do get a ticket from the link down below and join us for ProAV Academy.